Good day, Dr. Mohammad Nazri and all. Today, we would like to present our group report presentation for BMM 2623 Advanced CAT from Section 03, Group 6. These are our group members. I am Kashini Devalakshmi, MA 19280, and I'll be presenting Chapter 1 as well as Chapter 2. For the record, people with disabilities are among the most marginalized groups in the world. It is said that people with disabilities are those whom have poorer health conditions, they are lower in educational achievements, and less economic participation. Over 1 billion people live with some kind of disability. Well, we all know this happens because we contain a sense of pity whenever we see them and tend to help or do work for them instead of encouraging them to do it themselves. This also gives them a less opportunity of getting a good job or for further studies. The problems arise are that disabled people face difficulties to walk around even with a short distance. They cannot be limping or using a walking stick all the time because it is tiring and not convenient for a longer walk. Sometimes it is awkward and uncomfortable for them to ask help from others. Therefore, we have designed a wheelchair that has solved this problem for the convenience, that will solve the problem for the convenience of disabled people moving around without hesitation. The objectives of this report is to design a medium that can be used by disabled people to move around and assemble each component to form one convenient product. It is also our objective to generate the G and M code by using computer-aided manufacturing to show its cutting path movement for each component. The scope of this project is to design and assemble all the created parts and components of the wheelchair by using computer-aided design, and the software that we have used for this project is SolidWorks. Using CAM to generate G code and M code to achieve the cutting path movement for all components is also our scope. This is the Gantt chart and the progress of our report throughout these 14 weeks. Next, I would like to continue with Chapter 2 Literature Review. For the history and introduction, the wheelchair is a piece of technology that we are all familiar with. It all started when King Philip from Spain invented the wheelchair when he suffered from gout in his later years. The wheelchair consists of a plush upholstery, arm and leg rest, and 4 small wheels, which meant that he could push himself around without the help of his servant. And then in 1655, the first self-propelled wheelchair was invented by Stephen Fafler. That wheelchair only had 3 wheels, but he built it on his own mobility aid when he was only 22 years old, having a broken back. In 1910 to 1920, a chair with 3 main wheels and driven via chains by 2 hand cranks were invented. And later on, the wheelchairs were gradually designed and upgraded. These are the examples of wheelchair. As you can see, the top corner is where Sir Fafler in his 50s is sitting in his first wheelchair with just 3 wheels. And the right hand corner is a hand cranked chain driven wheelchair where it runs with a chain. These are the new features that we have implemented as a group into our wheelchair. First thing is we have implemented a safety brake. Next, there is a cup holder facility where it would be easier for people to keep their cup when they're having a good coffee or a tea. Next is a handphone holder, which also will make things easier for the user of the wheelchair. Our new redesigned wheelchair has a better ergonomics and is user-friendly. That is all from me. Thank you.
Hello, my name is Arun, Matrix ID MK19205. Today I am going to present about Chapter 3, which is the methodology. I'm going to start with the 3.1 project idea. We've discussed among our group members and come up with an idea to create a wheelchair as our project. We have modified the wheelchair into 15 components, as you can see from the exploded view below. Next is 3.2, which is the part assembly. We've completed the drawings using SolidWorks. Then we've created the drawings for the parts and we have completed the full assembly of the wheelchair. Next is 3.2.1, which is the component drawings. For this, I'll show you an example how the small wheel of the wheelchair is completed. First, we created the small circle. Then, using the cross section feature, we extruded the circle. For the larger circle, the same feature, which is cross extrude, have been used to extrude the circle. Then, we constructed a shape in the middle to create these holes using cut extrude. Then, by creating a plane, we constructed a bridge in the middle which connects the small circle and the bigger circle. We use the lock feature to construct this bridge. Then by using circular pattern, we created this pattern in the middle to increase it into multiple instances. Then finally, we use the cut extrude feature to make a hole in the middle which the pin will be inserted. So back to the slide. For the remaining drawings, I show you the PDF of the drawings. This is the arm drawing. This is the arm pad drawing. This is the drawing for the custom fork drawing. Footrest. This is for the grip of the wheelchair. And this is the large wheel. This is the pin and seat drawing. This is the switch for the emergency situation. This is the small wheel as I show you just now. This is the rubber cover that covered the extension at the rear of the wheelchair. This is the phone stand to hold the phone. This is the main frame of the wheelchair. This is the cup holder. While this is the backrest. This is the completed assembly of the wheelchair. This is the exploded view drawing, which all the parts are labeled with water balloon, and the description is described for every parts. Next is 2.3 generated MNG code. This will be further explained in the chapter 4. Lastly is the flowchart. This is the flowchart of our project, which we start by discussing and finding ideas for the project. Next, adding modifications. Next is creating parts and drawings. Then assemble the components, generate BMM code, complete the report and video presentation, and that's it. The end. Okay, thank you very much.
Hello, I am Levon An. I will present the chapter 4 result and discussion for our group project Advanced CAD. So for the chapter 4, we will discussing about the G and M code and the different angle of the drawing. So what you see in this is the complete third angle part from the few components we had designed in the SolidWorks. And then the extruded view and the complete assembly. The extruded view show the types and names for the different components, and for the assembly it show the full complete of the project design. Then we will talking about the GNM code. So the GNM code will be constructed out and export after we complete all the design for the components. So this is the example of the BMM code for our components that we designed, that is footrest. So let's see how we do export the BMM code for the components foot. So after you complete design for a component, you will need to press the SolidWorks CAM. You need to define the machine types. Then you need to select the available machines. You press OK. Then the coordinate system. You need to define the entity for the project. Later you need to press Stop Manager. So for generating the GNM code, for basic, we will start from the left hand side to the right hand side. The left hand side define machine, coordinate system, Stop Manager, setup. Later then you will extract the machinable features, generate the plan, and generate for the tool path. Then you will see the simulation. Now let me see how the simulation runs. We'll play it. This is the example for the simulation of CNC working process. After you have done all the defining and for the simulation, you can export the GNM code by pressing the post process. It will save as the txt file, that is the notepad file. Okay, that's all for my presentation.
Assalamualaikum and good afternoon. My name is Muhammad Shahmi bin Abdi, MA 20077. Today I will discuss about the conclusion. The wheelchair is one of the most commonly used assistive devices to promote mobility and enhance quality of life for people who have difficulties in walking. Wheelchair mobility opens up opportunities for wheelchair users to study, work, engage in social activities and access services such as healthcare. In addition to providing mobility, an appropriate wheelchair benefits the physical health and quality of life of the users by helping in reducing common problems such as pressure sores, progression of deformities, and improve respiration and digestion. Then, the wheelchair helps the disabled people that facing difficulties to walk around even within a short distance. The people can use the wheelchair compared to the walking stick that make them sometimes tiring and not convenient to walk for a long period of time. A wheelchair design was made to solve this problem for the convenience of disabled people moving around without hesitation. The SolidWorks application helped us including creating 3D parts and assembly design, engineering drawings, design evaluation using integrated simulation tools, and animation and realistic rendering. Okay, that's all from me. Thank you.